Hello everyone, hope all of you are doing great. And in today's video, we're going to have a look at the standard form of a number. All right, so the first thing that we need to learn in this lesson is how to write the standard form. The standard form actually, just before we start talking about this example that we have over here, we just need to know that it is always going to be a number that is between 1 and 10. So let's refer to this number as a times 10 to the power of n. So where a is always a number that is between what? 1 and 10. And n here is what? N actually is an integer. It could be a power, an index with a negative sign or a positive sign. It doesn't really matter. But the most important thing is that it is multiplied by 10 to the power of something. Okay, so let's start over here with this example. 5,700,000. We need to convert this into the standard form. How can we do this? All right, in order to do this, as we agreed, we need a number that is between 1 and 10. We need to get from this a number that is between 1 and 10. Okay, so I'm going to convert this into what? Into 5.7. All right. So I'm going to convert this into 5.7. Why, Mister? Because as we agreed, I need a number that is between 1 and 10. So here, the number that is between 1 and 10 that I can get is actually 5.7. All right. But if I need to get 5.7, we agreed 5,700,000 into the standard form. We agreed we get a number that is between 1 and 10. Done. You multiply it by 10 to the power of something. Okay, so now the only thing that is missing is the power. How are we going to write 5,700,000 in the standard form? It is equivalent to what? It is equal to 5.7 times 10 to the power of what? Well, definitely if you notice over here that I made this number way smaller. From 5,700,000, I made it 5.7. I need to compensate for this. I need to make it up. How can I make this up? We need to multiply by 10 to the power of definitely a positive number. I need to get this bigger. I need to make it equivalent to something that is bigger. So definitely the power is going to be positive. But what is the index? Well, let's see. It's 5.7, which let's assume it's here. I need to move it one digit, two digits, three, four, five, six. So it is 10 to the power of 6. And this is how we write the standard form. All right, let's move here to the next example. Just a second. Here, if I say to you 450,000, 450,000, and I need to write it here in the standard form, just like the first one. How can we do that? Okay. Yes, the first thing, I need a number that is between 1 and 10. 4.5. We multiply by 10 to the power of something. Oh, mister, this number that you have over here, did I make it smaller or I made it bigger? Yes, exactly. I made it way smaller. So definitely I need to compensate for this. I need to make it up. I need to solve this issue. I need something that is equal to this. How can I do it? Definitely multiply by a positive index. Okay, but what is the index going to be? Let's see how many times the point needs to move. One, two, three, four, 5 digits. So it is 4.5 times 10 to the power of 5 is going to give me 450,000. If you multiply this, definitely it is going to give us 450,000. All right, let's continue here with the next example. 21 million. All right, let's write this over here. 21 million, let's write it in the full form. or in digits. So 21 million is going to be this way. 21 and 6 zeros. I need to first identify the first significant figure. So here is going to be 2.1. This is the first part of the standard form. 2.1. Okay, definitely I need to multiply by 10 to the power of positive number. I need to make it bigger. I need to make it equivalent to this. So definitely it's a positive power. So 2.1, how many times did the decimal point move? 1, 2, 3, 4, 5, 6, 7. So it is going to be 2.1 times 10 to the power of 7. All right, let's have here a look at an example where we're going to need to multiply by a negative index, like in this one. Here, 0.007. How can we make this into the standard form? We agree the first thing we need a number that is between 1 and 10. So that's going to be a 7. Multiplied by 10 to the power of what? Okay. Now, mister, the standard form, the number that you have over here, it is gonna be bigger than the number that you are converting. Now you made it bigger, so I need to make it equivalent. I need to make this equal. I cannot make it bigger. I cannot make it smaller. I need them to be equal to each other. The standard form and the full form must be equal to each other. How can I fix this problem? Definitely, mister, you need to multiply by 10 to the power of an integer that is actually negative. It is negative something. Negative what? Let's see. From the 7, 1, 2, 3. 3 digits. So it is 7 times 10 to the power of negative 3. Okay. Let's move here to the next section. Writing non-standard form numbers in standard form, like this one over here. They're giving you 300 times 10 to the power of 4. And they might even ask you if this is a standard form or a correct standard form or not. Definitely it's not standard form. Why? Because the first number that we have over here is not between 1 and 10. It is 300, definitely bigger than any number that is between 1 and 10. How can I fix this? Make it into 3. So, okay, what is actually 300? Look at this. Converted 300 to standard form. Only 300? Yes, only the 300 converted into standard form. So 300 as standard form is actually going to be 3 times 10 to the power of 2. Now, it's 3 times 10 to the power of 2 times 10 to the power of 4, which is, you know that in multiplying, we add the indices. So it's 3 times 10 to the power of 6. Let's have a look at another example. Here, 54 times 10 to the power of negative 3. Well, mister, we need first to make 54 in the standard form. So it's convert 54 to standard form. It's 5.4 times 10, which is 10 to the power of 1. Definitely, we do not write the 1, but I'm writing it now just to show you and to help you imagine what is happening in a better way. All right, so now multiply 5.4 to the times 10 to the power of 1 times 10 to the power of negative 3. So 5.4 times, here you add 1 plus negative 3, which is actually 1 minus 3. It is going to give you 10 to the power of negative 2. Adding the indices, 1 plus negative 3, which is the same as 1 minus 3, which is equal to negative 2. So it's 5.4 times 10 to the power of negative 2. All right. The next section over here is finding like 1/10 of a number in the standard form. This is a very easy section. And if this question comes to you, it is a very easy one. All right. So what is 1/10 of 10 to the power of 23? Oh, mister, I'm going to just need to go down only one index. So I need to take the index only one step down, which is going to be 10 to the power of 22. That's it. 1/10 of 10 to the power of 18, 10 to the power of 17. 1/10 of 10 to the power of 54, 10 to the power of 53. That's how it works. It's that simple. So if I have a number in the standard form like this, and they say to me, find 1/10 of this standard form, 1/10 of this is going to be the same. 3.23 times 10 to the power of, oh, I'm going to take it one down. It's 13. That's it. 3.23 times 10 to the power of 13 is the standard, is 1/10 of this standard form. Next section here, if they say to you 3.4 times 10 to the power of 9 is how many times larger than 3.4 times 10 to the power of 6? Don't say it is 3 times larger. Oh, mister, it's 3.4, 3.4, 10 to the power of 9, 10 to the power of 6. Oh, it is 3 times larger. Wrong. It is actually either you're right, it's 10 to the power of 3 times larger, correct? Or you can write 1,000 times larger, which is 10 to the power of 3. They are the same. So you can write 10 to the power of 3 times larger. Here, 5.9 times 10 to the power of -7. How many times is it smaller than 5.9 times 10 to the power of 13? You're going to find that here it is 20 times smaller. No, not 20 times smaller. Here, the difference between the -7 and the 13, I have a mister here, 7 numbers until 0 and 13 from 0 until 13, it's 20. So it is 10 to the power of 20 times smaller than this. Don't get great crazy and decide to write 1 and the 20 zeros. Don't do that, please. Just 10 to the power of 20. All right, next. If I want to add numbers in standard form, like this one over here, they're giving you the 10 with the same index, 10 to the power of -5, 10 to the power of -5, and they're giving you 3.6 times this plus 2.9 times this. How can I do it? Don't waste your time trying to answer such a question and you say to me, I'm going to multiply 3.6 by 10 to the power of -5. No way. Don't do this, please. 10 to the power of -5 stays the same. Then it's multiplied by what? Multiplied by these two added to each other. So 3.6 plus 2.9, which is 6.5 times 10 to the power of -5. Okay, so again, I just added 3.6 and 2.9 and I multiply them by 10 to the power of -5. That's it. Okay, that's how we add standard forms. Okay, next part over here. Ordering numbers in the standard form is also very easy. If you have a lot of numbers in the standard form, like in this one here, I have A, B, C, D, E. So I got here 5 numbers written in the standard form. They are requesting from you to order them. So from least to greatest, look at this, smallest to largest. Smallest to largest, so I'm going to start with the smallest index. No matter what is there, I'm going to start with this because this is the smallest index. It is 10 to the power of -7. No, not 10 to the power of -6. This is still smaller. Oh, mister, I have another 10 to the power of -7. 10 to the power of -6. No, not yet. It's not smaller. 10 to the power of -7 as well is here smaller. It's the smallest. Oh, mister, I got 3 10 to the power of -7. Which one is the smallest? I have to look now at the other numbers there. These numbers, I have to look at them. Which one of them is the smallest? Yes, this one is the smallest, which is C. That's why it's written here in the answer. What is after that? I got after that a Mr. E. It's smaller than 9.8. Look at that. So that's why I have E next. After that, it is A. Good. Then I have -6, power of -6, power of -6. It is bigger than 10 to the power of -7. So which one am I going to take first? Compare the numbers that are there. Which one of them is smaller? This one, B. That's why it is there. Then D is the largest of them all. Next section, and it is actually the last section, is writing in full form. It is very easy as well. It's just a normal multiplication. If you remember, we took this actually in year 6, how to multiply decimals by powers of 10. Like for example, here I have 2.3 times 10 to the power of 4. What am I supposed to do? Move the decimal point to 4 places to the right. 4 places to the right. Okay, so in multiplication, you move the decimal point to the right. So here, if I have 2.3 multiplied by 10 to the power of 4, I need to move it 4 digits to the right. 1, I need 3 more digits. So it's 2, 3. I need 3 more digits. 1, 2, 3. So it's 23,000. And this is the full form. Okay, this is what they mean by saying full form. Good. So if I have another question like this one, for example, look at this. 0.007 multiplied by 10 to the power of 5. What am I supposed to do? Yes, we move the decimal pointer to the right. How many digits? 5 digits to the right. So 1, 2, 3. Uh-oh, I need 2 more digits. No problem. I'm going to add 2 more zeros. So it's going to be actually 700.0, which is just 700. This is the full form. The last question here, if I have a negative index, like what? Like if I say to you here 2.3, but it's multiplied by 10 to the power of -4, how can I write this in the full form? Very easy. Instead of moving the decimal point to the right, no, I'm going to actually need to move the decimal pointer to the left. 1, 2, 3, 4. So here I have 1, 2, 3 zeros, then the decimal point. Now I moved the decimal point again. 1, 2, 3, 4 digits. Because it's -4, I moved it 4 digits to the left. So the answer is going to be 0.00023. That's it, and see you in another video.